Now, this, I'm not going to lie to you, is probably difficult for you, but hopefully the way I explain it will make it a bit easier. So question 4, I want to prove n plus 1 ck equals to nck plus nck minus 1. And it's telling you that it's considering the coefficient of x to the power of k in the expansion of 1 plus x power of n. So now you can kind of see why we did all those practice ones before, right? Okay, so it's a prove question, which means that you want to show this side and that side. And because it's telling you to consider this, well, we're going to do what the question says, which is, let's consider the expansion of that. This expanded, remember, because the 1 to the power of n always equals to 1, we don't need to worry about it. So we have nc0 until nck x to the power of k. So this really is just our general term. And then nck minus 1 is just one term less than that. And nck plus 1 just one term more than that. So on until you have ncn x power of n, which is your last term. All right, now we want to find x, something that's going to give us x to the power of k, because it says here we want to consider the coefficient of x to the power of k. Now looking here, 1 times what is going to give us that? Well, it's going to be x to the power of k, right? Now, x times which one of these is going to give us x to the power of k? Yeah, great. It's going to be x to the power of k minus 1, because you can see here we're going to have x to the power of 1 times x to the power of k minus 1. So that means we add together our indices. So that equals to x power of k minus 1 plus 1. And that's how you get x to the power of k there. All right? So that's why that and that go together. Now we can just simplify that. So that is just nck x to the power of k. And you know how we showed here why this is x to the power of k? Yeah? So that's just nck minus 1 x to the power of k, which means that the coefficients of x to the power of k in this case is going to equal to nck plus nck minus 1. Yeah? Can you see how that's the coefficients by using that? So we've worked out the coefficients by considering the expansion of this. Now I want us to consider the coefficient of x to the power of k when we're considering 1 plus x to the power of n plus 1. So remember in the previous question how we had 1 plus x to the power of 5, 1 plus x? And I said a lot of you would be wondering why we don't just jump straight to 1 plus x to the power of 6. So that's kind of what we're doing here. This is power of 1, this is power of n, so this is exactly the same as 1 plus x to the power of n plus 1, right? Can you see? It's exactly the same. So now I'm going to consider the expansion of that, which is just n plus 1 c0, yeah? And this will be n plus 1 ck x to the power of k, right? And we'll finish off with n plus 1 c, n plus 1 x power of n plus 1. Now, because in this one, there's only one expansion, we don't need to consider what times what will give us n to the power of k. We can just look straight at this and see what is going to give us x to the power of k, which is that there, okay? That's the only term that's going to have x to the power of k. So by looking at that, what's the coefficient? Well, the coefficient is just n plus 1 ck, right? Which means that since we found out the coefficient of x to the power of k is this, using this method, and then we worked out the coefficient of x to the power of k is n plus 1 ck using this method, that means we've proved that from 1 and 2, therefore n plus 1 ck must equal nck plus nck minus 1, because both of these, yeah, they were the coefficient for n to the power of k, sorry, that's going to be x to the power of k. Yeah, so can you see how because we proved they're both the coefficient for x to the power of k, then we've proved they are equal to each other. All right, so I know this looks difficult, so let's just have a little revisor of what we just did. So the first thing was, the question actually tells us we want to consider the coefficient of x to the power of k. So that's why we expanded this one, yeah? And in this expansion, we considered what does 1 need to multiply by to give us x to the power of k? And that was x to the power of k there. And what does x need to be multiplied by? And that was x to the power of k minus 1. And then so we found the coefficients using that method was nck, nck minus 1, which you can see is equaling to the right-hand side there. Whereas then we use a method where we put these two together to make it 1 plus x to the power of n plus 1, yeah? And then we just expanded that, and then it was really easy to work out what x to the power of k was, because there was only one term that had x to the power of k, and we took the coefficient of that one, which equals to n plus 1 ck, which equal to the left-hand side there, right? And because they're both the coefficients of x to the power of k for exactly the same equation, then we can say, therefore, the left-hand side does equal to the right-hand side there from 1 and 2.